Welcome to Basic Rope Rescue. The purpose of this program is to train all members of our department in the use of basic procedures that we can utilize to assist in the rescue of victims from low-angle positions. This program will be delivered in 4 modules, some of which will be academic with the majority being hands-on. This is not a class to certify you at any of the rope rescue levels with the state. It is only meant to provide you with some extra tools to provide quality services to our citizens. The objectives for this module are as follows. We will discuss the basic incident management of rope rescue events, discuss safety precautions to be used in rope rescue, learn the different appliances and equipment that we carry, successfully tie the required knots and hitches, successfully rig various types of anchors, successfully rig and use various types of lowering systems, successfully rig and use a Stokes basket, and successfully rig and use various raising systems. We have divided this program into 4 modules. The first module will be entirely on FayetteCountyFire.com. In Module 1, we will present an introduction to rope rescue, incident planning and management, safety, and equipment and systems components. In Module 2, we will have some classroom, but the majority will be learning how to tie various knots and rig several types of anchor systems. In Module 3, we will cover lowering systems and Stokes basket rigging. A small portion will be classroom, but the majority will be hands-on rigging. The 4th and final module will be covering raising and ascending systems. As with Module 3, we will have limited classroom time and will spend the majority rigging systems in the field. NFPA 1670 is a standard on operating and training for technical search and rescue incidents. This standard is not just about ropes, but rather covers all technical rescue situations. This divides the rescue levels into a tiered system that you may be familiar with. The first level is awareness. By being trained at this level, you will be able to control the site and manage the scene, recognize and identify the need for higher trained personnel, and conduct non-entry rescue, such as coaching a victim for self-rescue. The next level is operations. Training at this level is a little higher than awareness, and you could be directly involved in the rescue. You can effect rescue in high and low angle environments, provide patient packaging and care, and perform lowering and raising operations. Operations is the level that this class should provide. The final level for technical rescue is technician. At this level, you receive advanced rope training, use complex mechanical advantage systems, use knot passing techniques, and manage rescue teams. The next set of NFPA standards is NFPA 1006. This standard establishes your job performance standards. This standard sets specific job tasks given requisite skills and knowledge. NFPA 1983 is a manufacturer standard. It regulates minimum breaking strength for rope, harnesses, hardware, software, and devices. It also states that the minimum breaking strength of the rope be placed in a ribbon throughout the rope. The first step in incident planning is completing a hazard incident analysis. Look over your territory. Do you have multi-story buildings, bridges, or steep slopes where an incident may occur? Are there any industrial facilities or water tanks? Which of these areas can you effect a rescue, and which scene will you need to call in a specialty team? Next is a needs assessment. Is it financially feasible to create a technician level team, or is it better to perform basic rescue and call in specialty teams as needed? Rope rescue at the technician level requires a lot of highly trained personnel that can train together on a frequent basis. In today's bad financial times, it is to our benefit to stick with just basic rescue. We carry a basic SAR pack with some additional equipment that allows us to first respond and handle basic rope rescue. We have the ability to call in mutual aid units from Clayton or Coweta counties if the incident is above our level of training. The response plan is divided into phases. Phase 1 begins at the time of the call. What information can you gather from the dispatch information and your prior knowledge of the scene? What is the time of day, weather conditions, potential hazards, and what rescues might be needed? Phase 2 is the pre-rescue phase. You will perform a risk-benefit analysis. Risk a lot to save a lot, risk a little to save a little. You need to establish your incident action plan that includes a site description, your organizational structure, hazard ID, work assignments, a backup plan, and communication procedures. Phase 3 begins the rescue. You will perform a safety check on all members and equipment, assessing and packaging the patient, perform the extrication, and utilize the accountability system. Phase 4 is termination of activities. During the post-incident critique, you will go over what went right, what went wrong, is there any additional equipment or training needed, and is there a need for critical incident stress debriefing. Communication is very important during the rescue. Simple terms and a face-to-face method is preferred over radio communication when possible. Hand signals are an option but are often difficult for the rescuer due to using his hands to control the rope. The following is the basic verbal commands to be used. Quiet means no one talks. On belay is the belay ready. Belay on means the belay is ready. On rappel, are you ready for me to rappel? Rappel on, I am ready for you to rappel. Lower, let rope out through the system. Raise, pull rope in through the system. Means decrease the tension in the system. Tension means increase the tension in the system. Faster is increase the speed. Slower is decrease the speed. Stop all. System stop immediately. Rope free. Rope is not being used for support. The system safety factor is in place to ensure safe working conditions with the rope and rescue equipment. The minimum amount should be no less than 10-to-1. To equate the minimum braking strength, you use the following formula. Find the minimum braking strength of the weakest component. Next, calculate the weight of the load. Finally, divide the strength of the component by the load. Example, you are expecting a 300-pound load and are using a piece of webbing rated at 6,000 pounds. This gives you a system safety factor of 20-to-1. System backup ensures that the failure of one component will not cause the failure of the entire system. To achieve this, we will rig a backup line or belay line to protect the rescuers and victims in the event of system failure. Prior to a rope system being used, you must perform a system safety check. The system needs to be pre-tensioned to ensure that all knots, rigging, and hardware are being used correctly. There are 2 stages to the safety check system. 1 is the buddy system, which is a hands-on, and 2 is the hands-off test. You will look to ensure that knots are tied correctly and dressed, carabiners are locked and loaded properly, pulleys are the correct size and reused correctly, the anchor is adequate, and all systems are operable. You will also need to perform a personal safety check of your equipment and make sure edge protection is in place if needed. Two materials used in the construction of rescue rope. The first one we'll talk about is nylon. Nylon will stretch 15 to 20% when placed under load. It can be pulled, bent, knotted, and loaded without significant damage to fibers. It can deteriorate in UV light. Acid and alkalis can break it down, and it loses considerable strength when saturated with water. The next material is polyester. It's a little bit stronger than nylon, and it loses less strength when wet. It has a higher resistance to UV light and considerable less stretch, usually around 2 to 4%. Life safety rope is constructed using 2 layers of protection. The first one we'll talk about is the kern. The kern is the core of the rope. It's a continuous nylon filament. It contains continuous tape that states it meets NFPA 1983, has a certification level, name of manufacturer, year, and quarter of manufacture. The mantle is the outer layer. It's the sheath of the rope. It adds strength while protecting the kern. The rope that we'll be using is called static kern mantle. There are performance requirements for light use life safety rope and general use life safety rope. Light use life safety rope is used for loads up to 300 pounds. It weighs less, has a breaking strength of not less than 20 kilonewtons, will not elongate more than 10% or less than 1% of the breaking strength, and its size range is usually from 9.5 millimeters to 12.5 millimeters. General use life safety rope is stronger than light use. for loads up to 600 pounds, has a minimum braking strength of 40 kilonewtons. The normal size is 11 millimeters to 16 millimeters, and it will not elongate more than 10% or less than 1% of the braking strength. The elongation of the rope refers to the amount of stretch that it will allow and is divided into static and dynamic. In rope rescue, we will use static rope. The differences are as follows. With static rope, you have a low stretch, has a maximum elongation of less than 6% at 10% of the rope's minimum braking strength. With dynamic rope, you have a high stretch rate. It's not approved by NFPA and it can absorb a great amount of energy. The difference that you may see is the ropes that we carry, that you'll hardly notice any stretch when they're in use. A dynamic rope would be more something that you would use for bungee jumping or more for recreational climbing. An important part of maintaining a rope is making sure that it is clean. To wash the rope, you will form it into a daisy chain and place it in a front-loading washing machine. Do not use a top-loading machine since the agitator can damage the rope. Air dry out of sunlight. After each use, you must inspect the rope. You will need to run the entire rope through your hands, looking and feeling for abrasions, cuts, burns, or core exposure, slightly bending the rope in the process to help with your visual inspection. You must maintain a rope log stating the date used, location, type of rope, type of use, damage noted, comments, and inspected by. This log shall be kept in the bag with the rope at all times. The PRUSIK cord is software that can be used as a braking safety system. It will hold 3,000 pounds before slippage occurs. It is constructed from static kern mantle that is smaller in diameter to your life safety rope, usually 7, 8, or 9 millimeters in diameter. This device is simply a short section of rope that is tied together using a triple fisherman's bend and is looped around the rope in a special manner to allow it to be used for braking. We use tubular webbing for our anchors. It is soft and supple and easy to tie. Its braking strength is in the 4,000 pound range. Harnesses are used by rescuers to safely secure them to the rope system. There are 3 classes of rescue harnesses. Class 1 fastens around the waist and around the thighs and is used for emergency escape. Its design load is 300 pounds. The Class 2 is similar to a Class 1 except that it has a design load of 600 pounds. We carry some of the Class 2s in our inventory on Rescue 10. A Class 3 harness fastens around the waist, thighs, and chest. It allows for multiple points of attachment and has a load capacity of 600 pounds. We carry 4 of these on Rescue 10. According to NFPA 1983, manufacturers are required to mark hardware with the manufacturer's name, intended load, whether it's general use, light use, or escape. The equipment that we will use will be of the general use variety. Hardware is manufactured in several different materials. First is aluminum. It's lightweight, usually an alloy to make it stronger. It's not readily corroded, and it's the most common that you'll see used. Steel has tremendous strength. It's inexpensive, but it does have a little bit more weight to it. And then there's stainless steel, which resists rust and has increased strength. This next slide we'll be discussing descent control devices. Descent control devices are friction-producing metal configurations that rub the rope and slow its movement. The first one we'll discuss is an 8-plate. It's inexpensive, it's easy to use, and it's usually used for just weights under 200 pounds and for use in heights under 100 feet. If you go over 100 feet, your extra rope actually acts as a belay and will make it more difficult to use. The descent control device that we will use is the open end rack. It's best suited for rappelling. It's a 28-inch piece of rod stock that's bent into a U-shape. One end is curled to form an eye. It's for use by right or left-handers. It has 6 brake bars, a hyperbar for lock-off, and it's usually made of aluminum or stainless steel. The rack is the closed end rack. It's used for lowering. It has threaded nuts on the end. no eye, and allows kernel rope to align its fibers to prevent kinking and coiling. Another type of hardware that we use is the carabiner. It's made mostly from steel for rescue. The parts are a frame, a gate lock, a nose, a spine, which is the major axis, the minor axis, latch pin, gate lock pin, and slot. The load should be placed on the long axis. Locking models are preferred for rescue. They can be manual locking or auto locking. Mechanical rope grabs are devices constructed to grip the rope for raising and holding loads or climbing. Force is applied to the rope in proportion to the amount of leverage applied and by the levering action of the cam. Pulleys are simple machines that transfer applied force from one location to another when used in conjunction with a flexible medium such as rope. We carry two types of pulleys on Rescue 10. We have the single pulley, which allows for one rope to go over the sheave, and then we have a double pulley, which allows for two ropes to go over the sheave. Using the diagram to the right, we're going to identify the different parts of a pulley. A is showing the side plates, B is showing the sheave, C is the axis, D is a becket, which is only on a double pulley, and E is the center plate. Most of our newer pulleys are PRUSIK minding pulleys. The PRUSIK minding pulley has wings at the bottom to stop the PRUSIK knot from entering the system. Remember, safety is paramount. You will quickly differentiate low angle situations that are beyond our scope of practice and start the necessary resources. You will be able to identify the equipment that we carry, and you will be familiar with the use of the rope and equipment carried on Rescue 10. This is the conclusion of Module 1.